Hello and welcome back to our video series where Niall and I sit down to discuss different things that are happening in the cloud industry. Today we are going to be talking about our recent announcement where we built a 3.2 million vCPU supercomputer in the cloud using AWS. So now, do you want to start us off by discussing the challenge that we were trying to overcome with this achievement, sort of a background on what we were trying to attempt to do?
Yeah, so what we were ultimately doing as part of building that very, very large cluster was doing virtual screening for a life sciences company. And what virtual screening is that a drug company will have a candidate protein or proteins that they wish to develop, and the development programs for drugs can, they're multiple years and very, very large investments. But one of the things you can do really upfront is to actually take your candidate protein and see how well it docks in virtual space, using compute against compounds that you can get from publicly available databases. The idea with virtual screening is that you, when you try and get to dock your candidate protein, you're looking to kind of search as wide as you can in the amount of compounds you're going to dock against. And you're also looking to see how many hits you get. Now, the idea really is that the more hits you get at this particular stage, and this is a very formative stage of the process, the better, the more likely you are to succeed as you move from the virtual world to the actual physical world, where you're actually going to be doing this docking physically and doing chemical analyses and testing and so forth.
Okay. So what was it that we actually did? How did we run this? Some of the technical information that led to this achievement?
Yeah, so what we did was we were running EC2 fleets from AWS. We were looking for spot instances across a different range of machines. And we were spreading those machines across 2 AWS regions. And we were using S3, which is Amazon's object storage, for both the seeding of the compounds plus the results, because the results, of course, are going to be very, very important in this particular case.
Okay, and what was it that Yellowdog could do that's unique that enabled us to achieve this?
I think there were multiple facets to it, and a lot of it boils down to the way that the actual platform is uniquely architected. So our workload manager or scheduler really is talking to worker threads, and those worker threads have capabilities, and they have capabilities and statuses. So am I up and running, and what am I doing at this particular moment in time? And that there is an abstraction between those worker threads and the compute. So for example, we can use a whole really wide range of compute across many, many different regions or locations, and across many different the main life cycle the main life cycle types in instances. So for example, on demand, spot, even using reserved or even on-premise instances. But what our scheduler sees is workers or worker threads. In this particular case, it sees over 46,000 worker threads and goes, okay, these are available for me to actually execute this virtual screening process. And we just dispatch the workload to them as they register with the platform and as they deregister, or as they're doing work. So that's really, from my perspective, that's very, very unique. Is effectively to use volunteer or commodity compute to get a huge amount of workload done in a very, very short or very, very small period of time.
Okay, so in terms of the cost mitigations that we had in place for this, you hear 3.2 million vCPUs, and you can imagine that must have cost quite a lot. So yeah, what was the impact of doing this financially?
So the key thing with cost is to make sure there's a number of things. The first key thing really is using spot instances. In this particular case, spot instances, we use them solely. That's all we used in terms of the spread of machines that we had. The other thing is, you know, you can look at the numbers in terms of the speed of processing and whatnot, but there's two main things. Is when you scale up, that you're scaling up and all of those machines are running and are fully utilized ASAP. And that happens to us. So we, you know, as we're spooling up machines, we're deploying workers on those machines and we're giving them work. So they're working at 100% as soon as they're ready from Amazon. And then on the way back down, once you start to actually execute the workload, you're going to have to bring down these machines. And what we do at Yellowdog is we bring those machines down when there's no further work to be done, so that they're coming down. Even though they're coming down gradually, they're matching the outstanding workload queue quite precisely. So really, if I was to summarize the cost mitigations, is, you know, where you can use spot instances, use them, but make sure you are on the way up in terms of provisioning up machines, that you, as soon as they're ready, get your workers on them, get them running, and when they're coming down, make sure that they're coming down at the right moment and coming down matching the remaining workload queue, so that you get this kind of nice slope up and slope down of instances coming online and coming offline once work is done.
Okay, and from my understanding, by using Spot, you do enter in an element of risk, don't you? Because they can then be taken away. So how does Yellowdog mitigate that potential risk to access the cost savings?
Yeah, I think for using Spot, it's horses for courses. You know, for some workloads, you do need to use machines that are available for the entire time that you require them. But for Spot, yeah, you have to be always aware that there is a possibility of being for those machines to be taken back by AWS. But what we do in Yellowdog is, based on the way that our scheduler works, is that we keep an inventory of all our workers. We keep an inventory of the workload queue. And once if we detect workers are lost, you know, which means that the actual a spot machine or instance has been taken back, we requeue that work, ask for more machines. In particular, if we are short on machines or instances based on the workload queue. But the key thing is being able to recover from that, and that's a really important piece, because you not only need your workload to be recoverable, but you need the way that you're actually distributing your tasks or your workload to these instances, also to detect that automatically and do the redistribution of tasks automatically. Because at this scale, if you have to do that manually, that's going to be a lot of work, and you just increase your operational risk and ultimately increase your cost if you don't do it that way.
Okay, brilliant. Thanks for that. And in terms of the drug discovery company, what is the significance of being able to do this virtual screening at the scale that we achieved?
So as I was saying, the key thing really with virtual screening is the higher that you can, the more hits you can get, the wider you can search the compound space, is more beneficial to you as you move through the process, so that the success parameters are more increased, because what you've done is you've screened as widely as you possibly can. And then as you start to kind of focus in on the compound, the docking compounds that make sense, you've already kind of done a lot of the work in terms of the spread that you've done the virtual screening at. So I think it's really important for them, you know, this was, I think, virtual screening of multiple millions, hundreds of millions of compounds, whereas if you're doing this on premise, you know, you're talking about 1 million compounds. So you have to be very precise with your search space, where in doing it in the cloud virtually, you can be a lot wider and picking up those compounds that you might not have already looked at.
Okay, and yeah, I guess that then opens up to smaller companies being able to use the same technology and reach the same scale if they can bring it up on demand.
That's correct, yeah, because the key thing is you're not investing, you know, for example, if you're a smaller company doing 1, 2, 3 of these per year, you know, you're not going to go out and purchase a massive grid for doing this. You can actually do this very, very easily in the cloud, and just add to that kind of nimbleness that you have with using cloud, and, you know, being able to bring it up at scale, at speed, get the job done, get out and get on with the rest of the process.
Yeah. Brilliant. So thank you for giving us that summary. If you'd like to read more details about it, you can find the blog on Amazon's website. As always, this video will be posted on our social media channels alongside our other videos. And if you have any questions, please do get in touch with us. Thanks for joining me, Niall.
Thank you.